Today we will be designing Uber, Ola like ride sharing application. So first of all, we will follow the regular interview like structure where we will start with the functional requirement and then we will discuss what all non-functional requirement are required. Thereafter, if we have any clarification required, take assumptions and everything, we will follow those things. Afterwards, we will come to the numbers estimation. So we'll estimate like how much our user base will be and how should that number will affect our components, services, and our overall high level design. Thereafter, we will briefly discuss about high level components, what all components will be required, and at the end we will deep dive into some components which are key component for that particular product, and thereafter we will wrap up. So this will be our whole flow for the designing any software system design problem. Today we will be taking care of ride sharing application like Uber, Ola, which are usually run in India, and Lyft, all there are other more which are run in abroad. So let's start by uh, defining our uh, functional requirement. So I'm just writing here, since we are designing Uber, Ola, Lyft, right? So this is our ultimate aim design. Now, first of all, here uh, we will see what all functional requirement we will be requiring. So let's say our functional requirements. So first of all, as we saw in the application, whenever we to these platforms, there we can see our nearby drivers, so that we can see like which driver is near to us and how much time that driver will take to reach to your location. So first and foremost thing is we can see nearby driver, right? Second thing will be like we can, after seeing the nearby driver, we can get the estimate time of arrival of the driver and of reaching as well, like to the destination whatever we have put. We will also get the ETA of reaching that location and estimated price. Like that can vary from uh, uh, from the vehicle to vehicle, like if we are using motorcycle or we are using auto or we are using car, depending on that, like that estimated price will be different based on the destination and the pickup point. Third requirement can be like we can book and do payment for the ride. Yeah, and last thing will be like we can track or ride at any point. Let's say we are in the ride and we want to see where we are going. Are we heading in the right direction or not? So we can do all of this tracking your location or your vehicle. That is also our functional requirement. Yeah, I think discounts and other things can also be added, but let's keep that out of scope for our interview because we have limited time. So we will exclude that part, right? Now when we come to our when we come to our uh, non-functional requirement. So non-functional requirement is basically uh, how performant or how good your system is as in terms of user experience. So basically functional requirement tells you the features, and non-functional requirement tells you how that feature should work. Like, should it be low latency, or it should be highly available, or what should be the requirement? So first of all, it should be low latency. Like, when you are searching for driver, you should be able to get any driver quickly, as quick as possible, right? And second thing is like your system should be highly available in terms of finding the driver in the location, right? If it is not available, then uh, people will face a bad experience and they will not come to the platform again. So in that terms, it should be highly available. Third thing is like a system should be highly consistent. So basically, when a system is highly available, it might not be that much consistent, but we can define some area where highly consistent in terms of payment, or in terms of driver allocation or trip, right? In those terms, it should be highly consistent, right? So there can be other thing as well, like privacy, or is your ride secure or not. Those can also be considered, but we are keeping them out of scope for this problem, right? So we have defined our functional and non-functional requirement at the top. Now, what we will do, we will go and we will try to bring the number estimation for this problem. So, so basically, let's say assume there can be few questions as well which you can ask to the interviewer. So let's say if you are designing a system like this, then one question which comes to my mind is like, is our service supported for one particular country, or like how it is running? Like, is it, what is the area? What is the area of scope? What is the overall area of scope? Right, so the answer can be like, it can be regional, or or at country level, right? So it will also give us a good estimation, like what database we should use and how we should effectively use it, right? So the other thing is like what all platforms we are supporting, right? So what platforms supported? So let's say we are at least supporting uh, mobile and desktop. Let's say we are excluding desktop for now because location service is little bit hard to get on the desktop. So we are primarily working on the mobile platform, that can be Android or iPhone, right? There can be one more question like, uh, uh, so in mobile, like, are we supporting app or and website both? Yeah, so it should be supported by both the platform, both the client platforms. And there is like, uh, let's say if certain user is in some region and there we are not supporting our service, then how how should we find like till what limit we are supporting? So let's say uh, what is the range of vehicle to be searches, or like vehicle. So let's say we are defining like uh, vehicle should be within the range of, let's say, 5 kilometer or something. Let's say these are just all numbers which so these are general questions which we can ask to the interviewer uh, in order to get some insights, right? Now, once we are done with these questions, if we have any other questions, definitely we should go ahead and ask, right? Otherwise, uh, let's move on to the next thing, that is the number estimations, capacity estimation. So for that, let's say capacity estimation. So let's say assume we are building this kind of platform for a country like India, right? So basically, in India, like there should be around 200 million users who actively use this kind of platform, right? In terms of using, now there will be at least 1 million uh, drivers or the riders, right, who are serving on this platform. So basically, on an estimate, uh, one user, one ride per day. Let's say this is the mean uh, average part, right? So there will be 200 million 200 million rides per day, right? So on average, like if we drill down this to uh, per second, so in a day there is around 10 to the power 5 seconds. So this divided by 10 to the power 5. So we will almost get 2000 queries per second, right? Which user are making throughout uh, our application in different location, right? Let's say if there are 1 million driver on our platform, and assuming of which half are working on the daily, so it will be like 5 to the power of 10 to the power 5 people who are serving uh, daily, or we can say at a time we are getting this many drivers, right? So if we get 200 queries, we can assume like our system is having lot of drivers, and for each query we have to, if we search for this long list of drivers and find the nearby driver, then it will become a very hard problem, right? So we need to find a way where uh, we can easily query nearby drivers for any user, right? So what we can do, we, let's say we have uh, this map, like the here the user is requesting from this location. Let's say move this location to this location. So this is, let's say this is our map of one city, and now we are distributing this whole city into a uh, grid of users. So we have broken down this whole city into, let's say, a 4 by 4 grid. Actually, we don't need this last column. So let me just delete these numbers. So basically, we have divided our Let me just give it a different color so that we will be able to see it, right? So we have divided the whole thing into two layers, right? We have these grids, right? So let's say we can get the latitude or longitude of any location, but we have to identify in which grid we are currently, right? So basically, you can assume there is a single grid, and that grid is again divided into four grids, like one, two, three, and four, right? So we can identify if latitude is greater than this or less than this. Similarly, we can reach to like this is our right grid, right? So let's say this is our right grid, then we can even bifurcate this grid into four uh, uh, small grids, and so on. We will be able to find in which grid our current user is, or what is the current segment of or of our user. Let's say a user initiate its request from here, we'll be able to identify like user is in this particular grid here, right? And thereafter uh, what we can do, we can start searching for drivers in the nearby nearby grids. So let's say if there are three drivers, one is present here, one is present here, sorry, one is present here, and one is present here, right? So like we know we are in currently in this particular quadrant segment. We know like what are its neighboring quadrants, and we should be able to find drivers present in those quadrants, and thereafter we will see like what are their latitude longitudes, and we can even find their aerial distance between this location and this location, and based on that we will request them to accept our ride, right? So the first thing was like how how do we get latitude longitude to segment that we can easily search by using quad tree kind of structure, where the whole map will be divided into four grid, and then each of those will be further divided into four grids, right? And the next question is like to find the nearby drivers, nearby segments. So this nearby segments can be easily built by building a doubly linked list or those kind of data structure. Let's say this is our node A, then this is B. So we can just write A is near to B, and A is near to A is near to B, A is near to B, C, and D. And we can get all the driver information, their location, and then we will request them, right? We will again discuss this as we will deep dive into our high level design. So let's move on to that part. So now here we should be able to okay. So let's say we start with uh, defining our drivers. So I have loaded this libraries here that will help me to design our diagram with more clarity. You can also browse library and add library here. You can just search system design and you will find a lot of good libraries like this. The system design components, simple simple design template, icons. You can just download them, and once you have downloaded, you can go back and they will be showing here. So let's say one driver wants to onboard. So let's say this is our driver. It it really wants to onboard to. So this is our driver, and it really wants to onboard. So what it will do? It will make a request. Let's say from his side, he will request to such platform. Am I eligible to join this particular thing? Then his query will come to a load balancer. So it will be kind of a first thing which will balance all the requests coming from the driver side or the user side. So initially this is our driver one. So this driver one will make a request to uh, our server via this uh, load balancer, and it will first reach to uh, WebSocket WebSocket manager that will initiate a connection of one of the server with the driver. So basically we want to maintain an open connection through which the driver and the server can talk without any interruption, because driver has to update its location, the server has to reach in order to give any trips if there are, right? So this WebSocket manager will in turn uh, uh, initiate a request to this. So it will initiate those requests, and those will be handled by WebSockets. So let's say there are WebSocket 1, WebSocket 2, and so on till WebSocket n, right? So they are happy to serve on the user behalf. So this load balancer is here, and WebSocket manager will also define this relationship between uh, driver and the WebSocket into a Redis cache, right? So it can easily get like uh, which particular WebSocket it is communicating. So here it will hold the relationship like D1 is communicating with PS1, right? And as soon as he become active, he will also set like this particular driver is online or is ready to pick uh, any trip, right? uh, Now once this is set up, like if the driver is new, he will also initiate uh, his particular information in the driver service driver info service, where it will uh, it will keep all the information related to driver, like uh, his vehicle information, or his contact information, or whatever the papers and other things are required. So this will be our driver, our relational database will be here. And like once this driver has been onboarded, it will keep continuously sending us the location. So this web socket will also, let's say, this web socket will also communicate with location service, that is a primary service which will be maintaining all the location related updates for the driver. So its primary goal is what we discuss. Like it will request map service to get the actual latitudes and longitude directions, right? Map service. It will get latitude and longitude from the map service, and then inherently uh, uses our algorithm which we proposed last time to classify that latitude longitude into a segment. So it will communicate with a columnar database, as like it will need to update uh, very frequently, like about the location changes. So you can assume like this database will be called very frequently, like maybe 20 seconds or something. Or location service will also send this particular driver location update information to event queue, or let's say Kafka in our use. So what we will do, we will, so that other services will be also able to use this information, right? So this will update this location information to Kafka as well. And here in this location DB, like we will be maintaining like D1 is at latitude, longitude, and latitude 1, longitude 1, and segment 1, right? And so as soon as, like, let's say if we have uh, sorry, let's say this is our, let's say our driver is currently present here, right? And let's say this is our driver, it moved to some other segment. Let's say if he moves to this segment, then this Kafka will update its location in the location DB uh, after every 20 seconds, but this information will be stored somewhere locally to reflect the latest latitude, longitude. If any service is required to fetch, they can get from Kafka queue, right? So the drivers will keep on updating their location. Let's say if there are multiple driver, they will follow the same route, and they will be like requesting, let's say this is the other driver. So once he will become online, he will also update, he will also request, or So he will also request our uh, load balancer, and this load balancer uh, will in turn use this WebSocket to define like if there is an entry or there is a WebSocket already available for uh, driver 2, right, who was earlier on offline, so he will maintain that particular state and define uh, the latest status of our new driver. So, and the same info will also be updated uh, in the driver info service and to the driver rational database. So both the driver are now continuously sharing their information, right? So let's say they both are sending their location. Now let's say one user is requesting for a ride, right? So he will be requesting a ride. He will he will be calling like, are there any driver available? Let's say he's requesting for ride, and uh, he will also be uh, making a call either from website platform or application platform. Then he will, at the first stage, he will also face a load balancer, and this load balancer will assign one WebSocket connection to our user as well. So you can assume this is a WebSocket server, and similarly, like there will be a Redis cache that will keep active connections. So this will be required to update user of any location of driver, right? So it will maintain like user one is connected to VS9, let's say, and he's active as well, right? Thereafter, what it will do, it will uh, what it will do, first of all, it will create that user account using this user service. So in the user service, it will create a information for the user, if he's what is his contact number, what are his like information, like maybe age, gender, or those things. So it will use those information in the future, uh, and since the user is requesting for a cab, it will call a cab finder cab request service first. So this cab request, this cab request service will in turn call the location service to get the user location, or eventually the segment in which the current user is, and this will also call uh, give the information of nearby drivers. So basically, by finding the nearby segments, like he can get the information of nearby drivers, and from those drivers, like the whole list of drivers who are nearby within the range, it will share to the cab request service. Now, cab request service will in turn call another service that will be cab finder or uh, cab finder service. So the primary aim of this service will be to initiate a communication with all the drivers one by one. So it will put that particular query in the message queue, and that will be again communicating with our WebSockets. So that will give the information to the driver via the WebSockets. Like, do you want to accept this ride? A user is requesting. Or once one of these driver accept or rides, it will in turn share that particular information to the trip service. So trip service primary goal is to maintain the status of any trip between two uh, users, like the user and the driver, right? So this trip service will initiate a trip related information, like this way is the trip ID, this is the user location, this is the destination, this must charge will be there. So it will maintain a regular update of the drivers as he's coming to the user location and even after when he's heading towards the destination. So it will implicitly use one other database that will be like for trip DB. So we are using a column database here as well because we know there will be frequent updates in the location, in the details. So we will be using a columnar database like Cassandra, right? And once this trip is completed, this trip service will initiate a call to the payment service, and this payment service will be the in charge of handling all the transaction related things. So here, since transactions are required, we will ideally be using a relational database. So that will help to keep our information more secure and more consistent, because those will be very acid transactions. So we want those kind of uh, database that can serve with a proper consistency. And once this trip is over, just for our analysis, we will archive this whole thing to our uh, archival service. So this archival service is primarily for trip archive. So it will in turn record all the information of the trip, like which path was taken, how was the driver speed, and was there any kind of those related information will be stored. So let's say this is a trip archive DB. So this will be responsible to like hold all the past trips, like how much payment and what path was taken, right? And this will again be used uh, for uh, prioritizing drivers, finding any fraud. So it will also be, this particular database will also be given to some uh, fraud detection or kind of some kind of anomaly detection service that can find if any path can be corrected, or whatever path the service has provided the driver has followed or not. What are all those things that particular uh, detection will be happen, and based on that, like, there will be correction in the path, and if there are any correction, the same will be propagated to the Kafka and thereafter to all the components, right? So this is a very high level diagram, like where we have learned how a user can request uh, a ride, and there are drivers who are continuously pinging their location and getting the rides which user are requesting. So we have gone through both the side of the platform. So our platform is serving all the functionality, like user can see nearby drivers easily by using this quad tree related data structure, and we can request for ride, book ride, and track our ride using these services. So I think everyone have got this problem. Now, if you have any doubt, feel free to write them in the comment box. Otherwise, thank you. I hope you have learned how you can design a Uber or Ola like system, right? And it might have helped you designing one. Uh, so let me just give. So if this particular problem has helped you learn the overall architecture of this ride sharing application, then do give it a like and share it with your friends who are looking for such kind of a high level design or understanding of such systems. I will be happy to help you with another problem in the next video. So stay tuned to my channel, do subscribe and share your love in the comment box. Thank you. Bye bye.